I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi's a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. So Avi, welcome back. It's been over a year since we've talked, so I want to start out by asking you for an update on the Galileo Project, which has been described online as the search for extraterrestrial technosignatures, using everything from anecdotal observations to rigorous scientific research. Can you refresh us with an overview of the project goals and some of the recent progress that you've had on it?
Yeah, so the project was inaugurated about a month after the first report from the Director of National Intelligence to Congress talking about unidentified anomalous phenomena. And of course, there are two possible interpretations. One is that the intelligence agencies are not doing their job. These are drones or other objects that are manufactured by adversarial nations. And of course, that's a major national security issue that and also a very unusual admission that they're not doing their job, if true. Of course, we all know about the Chinese balloon that was shut down, and that's an example for an object that was relatively large, and was only noticed after some alerts from citizens and people who saw it. And then the second possibility is, of course, that we are the last generation of people who know what it feels like assuming that we are alone in the universe. The cosmologists of the day say that the universe is pointless. And that's because when you look up the sky, you imagine a collection of particles, stars, galaxies, without life in it. But if there is a partner out there, an intelligent civilization, then of course the environment would not feel as lonely to us, and also we might be inspired to do better than we currently do on this rock that we call Earth, because we are obsessed with conflicts, with territorial disputes, identity disputes, while there is much more real estate out there. So it would be a major development if we realize that we are not alone. Of course, that is an even more important possibility, but obviously we should entertain the first one first. And unfortunately, those reports from the military, are anecdotal. People happen to be at the right place at the right time to see something unusual. And it sounded to me like we need a scientific approach to this subject. In other words, we should systematically monitor the sky with well-calibrated instruments that are under control and collect scientific quality data. Now, observatories used by astronomers are not suited for the task because they focus on a small region of the sky at any given time, and they are ignoring objects that fly overhead. They focus on distant sources of light. And so we had to design within the Galileo Project from scratch a new type of observatory that monitors the entire sky all the time in the infrared, optical, radio, and audio. So basically we're taking a movie of the sky, and then we analyze the data with machine learning software that we train on either artificial or real data. And as time goes on, these algorithms are better at identifying familiar objects and distinguishing outliers from them. And we reported the first results from the Galileo Observatory a couple of weeks ago in a scientific paper that was posted online. And it was a lot of work, 3.5 years to reach this point. For the first 2 years we're designing the observatory, buying the equipment, putting it together, assembling it. Then after that, half a year was dedicated to calibrating the instruments, understanding how they respond to various signals. And then finally, it was the data collection and the analysis of the data that took us about a year. And at the end, we have a very detailed scientific paper showing how rigorous scientific study of this of unidentified anomalous phenomena, UAP, should be done. And it was never done before to this level. I mean, of course, there are studies over short periods of time, or studies with instruments that were not fully calibrated and studied the way we did it. So I think it sets a very good example of how the research should be done. We have a lot of outliers within our data. We look at 500,000 objects over a period of 5 months. And the reason we have many more outliers than we should have is because we don't have distance measurements at this time. We're planning to have those within a few weeks. Once we employ multiple units that are separated from each other, we can do triangulation and figure out distances, just the same way that the two eyes that we have allow us to infer the distance of a predator. That's why we have two eyes and not just one. So we will do triangulation in the coming weeks, and then hopefully we'll be able to figure out the velocity, the acceleration of objects based on their distance. And so this is very encouraging. We also have funding for 2 more observatories. One we are currently assembling, and within a few weeks we hope to deploy in Pennsylvania, and the second one will be in a different state. So altogether, we hope within half a year to have 3 observatories that will give us of the order of millions of objects every year. And the point is, AERO, the All Domain Anomaly Resolution Office that was established after the first report from the Director of National Intelligence to look into past reports from military personnel, that office is unable to really dig into the data because it was obtained in the past and they can't really obtain new data on the same objects. And they concluded, at least in one report, that 97% of the objects can be figured out, although more recently they admit that there are even more that they cannot figure out. But from a scientific perspective, it's obviously a mixed bag. Most objects should be human-made, but even if 1 in a million came from outside of this Earth, that would be big news. And therefore, it's really the right approach to do a very detailed scientific study of millions of objects.
Well, and so I had a colleague who attended your recent talk at the Seoul conference in San Francisco. He was absolutely blown away. So congratulations on that. That was an amazing presentation from what I've heard. And
the video should be online, by the way, very soon. So perhaps by the time that this recording is aired, people can find the video. I should also mention that in my talk, I refer to the findings from an expedition to the Pacific Ocean to look for the materials from the first interstellar meteor. And we reported the findings in a published paper that was peer-reviewed about a month ago. And we found materials that have a chemical composition different from the solar system. And we really hope by summer 2025 to go again to the same site to collect bigger pieces of this interstellar meteor from a decade ago. And the bigger pieces will allow us to infer its nature, whether it was a rock from another star or a Voyager-like meteor that would tell us about another civilization.
Well, let me go back to the measuring equipment for a moment. The notes that he had taken said something about 5 different multi-domain ground-based sensors capable of measuring up to 60 kilometers in the atmosphere and a 3.2 gigapixel telescope that scans the entire southern sky once every 4 days. And so the thing that really blew him away is that you guys are generating terabytes of data. This is tons and tons and tons of information coming in. So I wanted to ask, how are you able to process this, or are you able to? currently?
Well, we store the data, and it will always be available to anyone that would like to look into it. And we will also share the tools that we use to analyze it.
Mm.
So that's the beauty of open scientific research, that if there is any unusual object that we definitely identify as an outlier after we measure the distance to, that would be a subject of a dedicated paper. So the reason that for now you see only discussion on a large number of objects is because we cannot say with any confidence that one of them or more are unusual. Because I always tell my team members, if we can identify one unusual object, that's enough for a paper. We
Yeah.
don't need more than that. Because if the data is good enough, you can demonstrate the case that it's not human-made or not natural from Earth. And that's what we are really seeking. And as long as we speak about a large number of objects, that's not good news. The good news will be when we focus on one object that is really behaving in a crazy way. And hopefully it will happen within a year or two. If there are objects like that in the sky, we'll find them. It's just like sending a hook into the ocean, and if there are fish over there, one of them will be caught. We don't need to pressure stubborn government agencies to tell us what they know. That's not necessary, because what we are curious about is objects in the sky, and the sky is not classified. The oceans are not classified, so we should be able to figure it out. We're barking at the wrong tree if we are trying to convince whoever has some data, to release it, because we can find the same data. And of course, the other type of data that we don't know much about is any materials from crash sites of unusual objects. And, here again, I'm not at all surprised if the government has a retrieval and reverse engineering program, because that's what you want to do when adversarial nations send equipment that crashes and in your territories, and you would like to know what technologies they're using. That's a very good way of doing it. So the only question is, did they recover any equipment or materials that are not human made? That's the only question, and the existence of such programs is not at all puzzling. And since we haven't seen any direct evidence for extraterrestrial materials as of yet, I don't know whether to trust those reports that we heard in Congress. It's really all about the data. And, if those materials were collected 50 years ago, they are not a matter of national security anymore, because the technologies used by other nations 50 years ago, are not really relevant to the situation today. We have much better. So if it's not human-made, then it's not a matter of national security. We should all know about it. And the best minds in the world, the best scientists, should be engaged in studying them. One last comment. You mentioned the 3.2 gigapixel data that will come from in 2025. It's not the Galileo Project Observatory, it's the Rubin Observatory that was funded by the National Science Foundation and will start operations in Chile. And together with my students and my postdocs, we're planning to use that data to search for UAP, but also for interstellar objects like Oumuamua that was discovered in 2017 that look unusual. And there should be many such objects found by this telescope every year. So here we developed the software with the Galileo team to look for such objects within the data stream that will be publicly available. And I very much look forward to that.
Well, so let me ask about the upcoming Roman Space Telescope that's scheduled to launch in 2027, as well as the Habitable Worlds Observatory that is anticipated in the 2040s. And the reason I mention those is you have just kind of segued into discussing space science and astronomical observations, right? And so these optical telescopes are supposed to take things to a whole new level. Hopefully, from what I understand, basically NASA will be able to look at the chemistry of other worlds. But I don't think they're going to be looking for technosignatures. Is that something that Galileo will be able to use data from?
Sure, but one caveat about the Habitable World Observatory, that is a project that will come to fruition probably within a few decades. It's not immediate because of the expense. It will be tens of billions of dollars. And moreover, there are lots of technological challenges in constructing it. The goal is to focus on individual star systems. So it will have a narrow field of view. And of course, it could be sensitive, for example, to technological signatures of the type of SETI lights. If you look at a planet that moves around a star, if it transits the face of the star, you see a reduction in the flux of the light that comes from the star. And this particular observatory would be able to detect, for example, oxygen or other molecules that might be indicative for life in the atmosphere of the planet. As the light from the star is passing through the atmosphere, you can look for the spectral fingerprints of those molecules. But another thing it could do is, we are familiar with the phases of the moon. There would be also phases of the planet as it moves around the star. And there should be one side, the night side, that is dark, and the other hemisphere that is illuminated, the day side of the planet. If there is artificial light on the night side, if there is a civilization that lights up the night side more effectively than we do, then the night side will not be dark. And that's something that the Habitable World Observatory can look for. Another thing it can look for is contamination of the atmosphere with industrial pollution. For example, those molecules, CFC molecules that refrigerating systems produce on Earth, could be detected. These are molecules that are not produced by nature, only by industries, and one can look for them. I wrote the first paper on this subject 2015 with an undergraduate student, Henry Lin, and I also wrote a paper with another undergraduate about 5 years ago on detecting city lights. So these are the kind of technosignatures that the Habitable World Observatory could look for. The Roman observatory will just survey the sky, but I'm much more hopeful that we will know by then from the Rubin Observatory starting in 2025, we will already have a census of objects near Earth that are of great interest because they come from interstellar space. So really my hope is within the coming a couple of years that we will know much more than we currently know. Because, without seeking evidence, you will never discover anything. So the good news is right now, the Galileo Project observatories will collect evidence on millions of objects near Earth. And then the Rubin Observatory will go even farther and find objects that do not collide, do not come very close to Earth, that are maybe within the orbit of the Earth around the Sun, the size of a football field or so. And one such object should be observable every month or two, based on current estimates. So I think once we start detecting those interstellar objects, we might see that among the rocks there is some space trash from another civilization, and obviously their trash is our treasure.
Well, and yeah, and sorry, I just want to pause for a moment. You absolutely blew my mind with this idea of viewing cities in another star system through a telescope. I love big ideas like that. That is probably the most exciting thing I've heard in months.
Oh, thank you. I actually came across this idea back in a decade ago, and the context was I was visiting Abu Dhabi and Dubai, and the tour guide there was bragging that you can see the lights of Abu Dhabi all the way to the moon, and from spacecraft, and that raised an interesting question. Suppose you are looking at Abu Dhabi or a city like Tokyo on another planet. How far can you see it with the Hubble Space Telescope? And I calculated you can see it all the way to the edge of the planetary system around the sun, about 100 times the Earth-Sun separation. The Hubble Space Telescope with deep exposure could detect a city like Tokyo all the way out to the Kuiper Belt. And then I asked and of course, you can tell the difference between artificial light and a reflection of sunlight, because reflection of sunlight dims very quickly as the object changes its distance from the sun. It goes like the distance to the fourth power, because the fraction of sunlight that is impinging on the surface declines inversely with distance squared, and then there is another factor of 1 over distance squared in terms of what we see from the source. However, if it makes its own light, then it's just like a flashlight or a lamppost. Basically, the flux decreases with increasing distances inversely with distance squared, not distance to the fourth. So you can tell the difference. And I asked an astronomer from Caltech, Brown, and I said, you detected a lot of objects in the Kuiper belt. Did you ever check whether any of them changes its flux inversely with distance to the fourth or distance squared? And he said, why would I check it? It's obvious that all of them just reflect sunlight. And this shows, in a nutshell, why discoveries are not made very often, because people assume in advance the answer.
Yeah. Well, so this goes to this larger question of life in the universe, life elsewhere in the Milky Way galaxy. So Frank Drake had estimated that there are likely to be 10,000 intelligent civilizations out there in the Milky Way. And for each of those civilizations, there may be millions of planets with primitive life of some kind, and potentially thousands more with ancient ruins. So one of the things that excites me is this idea that the Milky Way is filled with life, right? And even though it's few and far between, I mean, we've got 200 to 400 billion stars to work with. Do you have any guesses about how prevalent life may be, even in our galaxy?
Well, we have to keep in mind that there is the time domain as well, and there could have been many more civilizations over the past billions of years than there are right now, because, for example, our sun within 7.6 billion years will become a red giant and eventually engulf potentially the Earth and then fade away as a white dwarf. The core of the sun will shrink, about 60% of the mass of the sun will condense to a region the size of the Earth, and then it will just fade away. And so clearly, life on Earth would not survive that evolution of our sun, and the Earth will become either will end up at the center of the white dwarf, because it will be the friction of the envelope of the giant star will bring it to the center. And by the way, another tidbit is, before it does it, the moon will lose its angular momentum around the Earth and will spin inwards and eventually collide with Earth. So the moon was formed out of Earth as a result of a collision. If the sun engulfs the Earth-Moon system, the moon will return to Earth, which is an amazing thing. It will collide with before the Earth ends up at the center of that star. But obviously, life will not be possible at that point. And the sun was born in the last third of cosmic history. And so most of the stars formed billions of years before the sun, and they already are representing our future, the future of the solar system. So first of all, what that means is that some of those civilizations could not have survived on a habitable planet, because the planet was not habitable after that period when the star evolved. And we were not around to listen to the cries for help. So if you ever search for signals out of desperation from other civilizations, you should check stars that are about to burn up their planet, because at that point the civilization needs exodus. They need to leave their planet, and they might cry for help, because not all of them can board spacecraft. In fact, the real estate value of everything on that planet will plunge, and the tickets to go on Starship like craft would skyrocket, because everyone would like, it's sort of like Noah's Ark. You want to go on it to avoid a catastrophe. And so a lot of civilizations may have gone through that. We were not around to witness that.
Yeah.
And we are not thinking about that, but surely there were many of them that perhaps reached our technological stage or even more, but they are dead by now. They perished, and maybe some survivors left on a spacecraft and they're somewhere else. I don't know if they survived in the long run. So that doesn't mean that we will not find signatures for them, because
Yeah.
we might find those spacecraft that they launched before their planet became was burned up, or another possibility is that we would see evidence for any mega structures that they built that are still around even after they died. So even if we look at a planet that does not have any life on it, we might see evidence that there used to be technological life on it, uh, either in the form of infrastructure or some, if there was a global nuclear war, there might be some isotopes that are more abundant than you find in nature, or things of that. Or they may have left the lights on. That's another possibility.
Well, so you've written extensively in the past about AI astronauts, and this is something that really excites me because this civilization component of the Drake equation, right? This life cycle of civilizations, and as you said, planets and star systems themselves, it is not forever, and we are kind of latecomers to the game in terms of when our solar system, when life began here. But these AI astronauts may be out there. These technosignatures could be out there, right? And you'd mentioned like Oumuamua may be one example of that, where these relics of long gone civilizations are just out there waiting to be explored. And UAP may represent the same thing, right?
Right. So Oumuamua, it was pushed. There was non-gravitational acceleration. It was most likely flat, and so my possible interpretation, is that maybe it was a surface layer torn apart from a bigger technological object, or a broken piece of a megastructure like a Dyson sphere. That we don't expect Dyson spheres to survive because after a while the star evolves and the radiation pressure would break the Dyson sphere
Yeah.
apart. So you would find pieces of broken Dyson spheres in interstellar space. Now, functional devices are different. You can imagine von Neumann probes that replicate themselves, so then there could be many more of them. It's sort of similar to the dandelion seeds that are sent by the wind and make more flowers of that type. So nature obviously has this principle employed, where the DNA is replicated again and again through the seeds, and technological civilizations may have adopted the same approach. And in that case, it's sufficient to have only one civilization that adopted it in our past, because by now, this process is exponentiating. If one probe makes two and the two make four and so forth, then within a billion years, you can fill up the entire Milky Way galaxy with
Yeah.
probes. And that's something we might find in our backyard. And all I'm saying is we should not imagine anything. We just need to collect data and seek the evidence, because nature is very often much more imaginative than we are. We tend to imagine. I mean, you may rely on science fiction movies, but that is limited by the Hollywood directors. And when we go on a date with a human, we can imagine what that human looks like, because that human shares our DNA. But when we encounter someone from another star, all bets are off, because it could be something very different from what we experienced in the past.
Yeah. Well, and all of these things were in your recent book, Interstellar. So I want to touch on that, and I will put links in that to the show notes, right? So that people have that to reference. And it's an amazing book. You have covered so many different topics in space science and technology. You also start to move towards the singularity, which I think was really interesting. You've discussed your relationship with Stephen Hawking in the book, along with his warning about artificial intelligence possibly spelling the end of the human race. So do you think that some of the current discussions that we're having in terms of UAP, artificial intelligence, the singularity, things along those lines, Do those offer us a glimpse of our own future? And do you think that we have the opportunity to avoid mistakes that may have destroyed or at least hindered other civilizations?
Definitely. I mean, ultimately, that's the best practice of learning from history. You may ask, why should we learn about the past? And the answer is because we want to avoid the mistakes that were made in the past. Okay, and if we see other civilizations, in fact, if we had a census of what happened to them, we can avoid any catastrophes that they encountered. And those could be the result of self-inflicted wounds if they, for
Yeah.
example, had conflicts on their planet, if they behaved as we do right now in terms of the geopolitics that we have, or as a result of some natural catastrophes like an asteroid hitting their planet, a supernova exploding, or their star having a giant flare that caused a lot of damage. And just by surveying the whereabouts of other civilizations, we can protect ourselves better. So, if I were a historian, I would really like to know the history of all civilizations that predated us over the past 13.8 billion years, because we can learn a lot from that. Now, on Earth, we only have recorded human history over the past 5,000 years. That's a tiny fraction of the history of Earth. It's 1 millionth. And we don't know actually what happened before that. And it's quite possible that we were visited uh, even before humans arrived to the scene. Humans just arrived over the past few million years, which is 1 part in 1,000 of the age of the Earth. And so it's possible that some of the events that we associate with natural causes may have been affected by visits from technological civilizations that had an agenda. We don't know what the agenda was because humans were not able to record those events. And so, when Enrico Fermi asked, "Where is everybody?" that was a very narrow-minded focus on
Yeah.
his time having lunch at Los Alamos. And my point is, when a lonely person says, "Where is everybody?" you often tell that person, look, you are not that attractive. You can't expect them to be just next to you. You really need to make an effort, go to dating sites, observe, the streets from your window and figure out where is everybody. And frankly, Enrico Fermi didn't build a telescope like the Galileo Project. He didn't search. And if you look at the history of science, we would never discover the Higgs boson if we didn't invest $10 billion in the Large Hadron Collider. We would never find the first galaxies if we didn't invest $10 billion in the Webb telescope. So why would we expect to see evidence for extraterrestrial life without investing the effort and the money? And frankly, I don't think it's an extraordinary claim to assume that we are not alone. I think it's actually extraordinary to assume that we are alone because, the Copernican principle suggests that we should not assume that we are privileged. We are not at the center of the universe, and probably we are not at the center of the intellectual universe either. And to find out more, we just need to search for data. No, but the reality is under no obligation to make us happy, to make us important. We tend to think that we are the focus of attention. Even religions imagine God watching over us. And I say, we are not that significant. So we should approach reality from a sense of cosmic modesty. Let's assume as the default that things like us existed for billions of years. And obviously it's not easy to find them because look at us, how easy it is to build a telescope that would see us from a distance of tens of thousands of light years. It's really difficult because the signatures are not easy to detect. And also because the era during which we transmitted radio signals is less than a century, so a century is is a tiny fraction of the history of Earth. So unless you listened exactly at the right time, you would not find it. And we we launched 5 probes to interstellar space. It would take them 10,000 years to leave the outskirts of the solar system in the Oort cloud. So, it's not easy to find evidence for others, but without searching, obviously we will not find it. It's a circular argument, and I think it's very narrow-minded to suggest that we are alone. Just think about islands in the ocean. If you're not boarding a ship, it's difficult to know if there are people on other islands far away. And of course, you might search for trash that may have arrived to your shore on the island from other islands. And that's what the Galileo Project is trying to do.
Yeah. Well, and again, the mission is so remarkable. And, in terms of narrow mindedness, I think the irony of the Enrico Fermi story was I learned not too long ago that when he said that, where is everybody? He was actually discussing and looking at I believe it was an issue of the New Yorker that showed a 1950s era UFO with space aliens abducting trash cans from New York City, right? And so it was a joke that in itself contained the seeds of here are, UAP, here are UFOs with aliens that were represented at that time. And he's looking at that saying, where is everybody? Okay, well, it's right there in front of you. So,
well, the other point is without investing funds in the search, we will not discover anything.
yeah.
So, for example, the expedition to the Pacific Ocean that we hope to make in summer 2025, that will cost $6.5 million. By measures of scientific projects, it's not a lot of money. The biggest projects, as I mentioned, cost $10 billion. So I think just like in the search for dark matter, where we invested billions of dollars, we haven't found yet what 85% of matter in the universe is. It's a substance we've never experienced. And we are willing to put those billions of dollars to look for it. I think an even more urgent question that would affect humans far more is whether there are dark civilizations out there that we haven't yet detected. And we should spend billions of dollars on this question before we pretend to have a hint as to the answer. And instead, this is not being pursued. There is a stigma within academia. I find it completely inappropriate because scientific curiosity should be guided but by what the public cares about, what would change human history. And now that we have those instruments that allow us to address this question, we should definitely employ them in this direction.
Yeah. Well, and in terms of getting involved, people should definitely visit the Galileo Project website, and they can donate there. They can get involved. They can learn more about the extensive. I mean, you have a large number of people who are involved with this. So this is not a small effort anymore.
No.
Last time I looked, there are dozens and dozens of highly credible PhD level scientists, professors, engineers, professionals who are all donating their time and energy. And if people want to donate money, they can do that on the Galileo website, right?
Yeah, so people are, very excited about it. And I should say the excitement extends also to the arts, which is a very interesting thing. I mean, first, there will be a Netflix documentary released within a year about the expedition. They came with us to the Pacific Ocean. Yesterday, I had a visit by the great American sculptor, Greg Wyatt, who decided to donate 2 new sculptures in bronze of Galileo Galilei. And I showed him my office where they will be positioned. They will be delivered within a few months. And I will basically get rid of several file cabinets so that they can be displayed there. And they're beautiful. He made them, and he's regarded as the American analog of Rodin, very distinguished. And he was inspired. He just saw what I do and decided to donate them very generously, and came to visit my home yesterday with his wife, Faye. And that's one example. There is another sculptor from Spain who is finishing another sculpture, but that will be in wood. That was inspired by Oumuamua. And then there was a play that was written about my work as well, and hopefully it will be presented in a theater, in the coming year. There was music inspired by Oumuamua that was already performed in a concert hall, and altogether, I think, and there are poems that were written. I think that the idea of finding our partner in interstellar space appeals and inspires people. And, we could find better role models than our politicians out there. We might find a messianic message. It will not be from a human on Earth, but from someone next to another star. And it will be the biggest discovery in the history of science, and therefore, just the way that Pascal had a wager. If Pascal argued that one should consider the concept of God, because the implication would be huge if God exists, and therefore you can't ignore that possibility. And I argue the same about extraterrestrials.
Yeah, yeah. Well, and that reminds me of Carl Sagan's message in Contact, the movie Contact with Jodie Foster. They had talked about loneliness and just reaching out, right? Reaching out to learn and share and, connect, I guess.
But the thing is, in the past 7 decades, the traditional approach of SETI was to look for electromagnetic signals, radio signals. That's just like waiting for a phone call at home.
Yeah.
Nobody may call you when you're waiting. The approach that the Galileo Project is taking is looking for packages in your backyard, in your mailbox. Even if the sender is dead, they would keep accumulating there. The probes that we launched are moving 10 times slower than the escape speed from the Milky Way galaxy. So they will accumulate over time by all civilizations over billions of years, just like plastics in the ocean. And that's why the second method might actually be the first to advise us as to whether we have neighbors.
Amazing, amazing. Avi, let me close for today by thanking you so much for your time. It is truly an honor and always a pleasure to have you on. Again, I want to remind people about your book, Interstellar. I will put links into the Galileo Project website where they can learn more about what you're doing. Also, I want to close things out by asking what is coming up for you in the next few months of 2025?
Well, some of the things that will come up would be very exciting, but I can't discuss them as of yet. Here I'm referring to things beyond what I already discussed. But there is a new book. I'm about to sign a contract with MIT Press on a new book that will describe the expedition to the Pacific Ocean. That's a new project that is exciting. More data from the 3 observatories of the Galileo Project obviously will be very exciting. The data from the Rubin Observatory should be very exciting. So I think next year promises to be very exciting. There are 2 more items that I unfortunately I cannot discuss at this time, but they will come out if they come to fruition. You will hear about them quite prominently.
Amazing. Thank you again so much for your time today, sir.
Thank you, Tim. It was a pleasure as always.